What? Your packet. What?
Mom.
I think that's what they're for.
Alright, so we're going to give Livy our attention, but the little half sheet of paper that you picked up when you came in, those are the answers to today's homework and what's due tomorrow. So like on the left side, all the solutions to the homework that you have in front of you are on that half sheet, and then on the right side are all these solutions to tonight's homework. So make sure you're checking those solutions as well. Okay, Livy, okay, talking.
So on number 1 on the inverse worksheet, I did f and then gx, and so for gx I put in negative 0.5x minus 1.5, and then that was and then I did negative 2, and then in parentheses negative 0.5x minus 1.5 minus 3. And then I FOILed that, and then I got 1x plus 3 minus 3, and then 3's canceled out, and I got x. And then for the other one, I did gfx, and then for the fx, that was negative 2x minus 3, and then I made it negative 0.5, and then in parentheses negative 2x minus 3, and then minus 1.5, and then I FOILed that, and I got 1x plus 1.5 minus 1.5, and then that made it x.
So remember the 1 and 2. Those two problems were the ones that you were asked to verify or confirm that f of g of x is equal to x. So that's 1 and 2. You weren't finding the inverses, you were verifying them. Nice job. Alright, so if you will look at number 5.
Okay, so for number 5, you had to find the inverse of 2x plus 5, the square root of 2x plus 5, and so I swapped the x and the y because that's what you do for inverse. And then to get rid of the radical, I squared both sides, which then got x squared, and then 2y plus 5. And then I subtracted 5 from both sides, so then it was x squared minus 5. And then to get the 2 away from the y, I divided both sides by 2. And so it was x squared minus 5 over 2.
Wow, I'm stupid.
You're not stupid, Nina, don't say that.
Before you put it down, can you just put it back up here? Sorry.
Oh my god.
I'm just stupid.
So to get rid of the square root, you have to square both sides, which is why he has x squared up there. There's one little teeny tiny thing about the answer. It's not wrong.
Oh, yeah, it might be plus or minus.
No, not plus or
Oh,
minus.
it's not.
Yeah, so all of your problems, after you work through it and you have down here you solve for y, the last step is to take that y, you have to write it in inverse notation. So I know it's just a notation thing, but then that's the part that truly says it's a relationship with the first problem, that they are inverses of each other. So just having this as y equals doesn't relate it back to the original problem that you were working with. So make sure all of the y equals should say f negative 1 of x. So after you find the inverse, I know it's just notation, but it really is important notation to have. Nice job otherwise, Josh. So look over your paper right now with the answers, please. Take a minute to check the answers.
Why is he so into that stuff? I don't know. You are That's artist. Nice. Yeah.
By definition, to determine or verify all
Take it away, Chelsea. Why was this
I was just gonna say. Never mind. Who? Are they? No, I was like. Oh my god. And did you have to like read how I knew that. Why did I just ask?
All right, so I would like to look at the other page of homework, which was on the composition of functions. So the first page was just the inverses, and then the second page was a little more work on the composition functions. So if you look, it says example 1 at the top. You didn't have to do the other page that really just had like extra notes. So we're just doing those 4 examples on the back. Letter B says g of f of x, and then it also says to state the domain, but the first thing we want to find is g of f of x. And at the top it gives you the f of x is 7x plus 1, the g of x is 2x to the negative 1. So using the composite function information that we did on Friday, whatever's in the middle, that's the part you take out. So f of x is inside. We're going to take out the f of x and replace it with its equation. So now it says g of 7x plus 1. And what do you do with that part then to do like finish the composite function?
Plug it in for x of the g.
Right. So we're going to take whatever's inside and plug that exact same thing in for x in the g equation. So the g equation says 2 and then x to the negative 1. So instead of writing an x here, we're replacing it with 7x plus 1. And literally it's substitution. So all of this gets to go inside the parentheses. So now we have 2 and then parentheses 7x plus 1 with the little negative 1 exponent. So when you have a negative exponent, what does that negative exponent really mean in the problem? What does it do to the problem when you have a negative exponent, Chelsea?
That part goes to the bottom.
Right, that part that has a negative exponent moves to the denominator. Not all of it. So the 2 in front doesn't move because it doesn't have a negative 1 and it's not attached, like they're not glued together. They're allowed to separate. So the part that's negative 1, to make that positive, that whole thing goes to the bottom. So this piece is moving down. And it's going to go underneath the 2. So the 2 stays on the top. The 7x plus 1 is now in the denominator of the fraction. And then that's as far as you can simplify it. There's nothing else that would reduce or cancel. They're not all divisible by the same thing. So g of f of x is 2 divided by 7x plus 1. And that whole thing moves down because it was in parentheses with a negative 1 on the outside. So the other part of the problem then said to state the domain. Well, if you have a fraction, what's going on with the denominator of a fraction, Cooper? Or what can't be in the denominator of a fraction?
0.
It can't be 0. So what number would make it 0 then, Cooper? So if you solve that little equation down there for x, you're really close. Negative 1, 7. So you'd subtract the 1 to the other side. So if you're solving this equation for x, we'd subtract 1 and then divide by 7. So x cannot be negative 1, 7. Our domain then is every other number but negative 1/7. So when we write that, we say negative infinity to negative 1/7, and then negative 1/7 to infinity. So going down to letter D, letter D's solution should just be x, and only x, no number with it, just the letter x. So letter D says take g of x, and just to remind you, g of x is 2x to the negative 1. So that's my g of x function. So if we're taking g of g, so the inside part gets replaced. So we're taking out the inside, replacing it with its matching equation. So now inside we have 2x minus 1. And just like the previous one, whatever's inside here replaces x in the g equation. So instead of writing x, we're going to have the 2 outside, and then whatever's replacing x is to the negative 1, because it says you have 2 times x to the negative 1. So here's 2. Something's going to replace x, that's the substitution part, and then to the negative 1. Well, the part that's replacing x this time is also 2x to the negative 1, because I'm plugging it back inside the same exact function. So if we use exactly the same process that we used up here, like the same logical thinking or reasoning through the problem, if something is to a negative exponent, and that would be this outside one, so you work from the outside, kind of looking at that outside exponent. This part is negative, it gets moved down just like we did for letter D. So the 2 stays on top, this 2 stays on top, but everything else in the parentheses has to move down. So then it becomes 2x, but it's still to the negative 1 inside because this part was inside parentheses. We're worried about the outside of the parentheses right now and shifting that down. So 2 on the outside, that's from this outside 2. Everything that was in parentheses had a negative 1 exponent, so that all shifted underneath. How does this continue to simplify? Scott, what do you think? What else can we do to simplify it?
Divided by 2.
Yeah, we have a 2 divided by 2, so that cancels. What else can simplify? It's valid. Like, why would you bring the x on top? That's right. Right, so if it's on the bottom and it has a negative exponent, the way you make it a positive exponent is by moving it to the top. Pretty much you're doing the opposite. So if the exponent's up negative, you move it to the bottom to make it positive, but if it's already on the bottom, then we move it back to the top. That's how you just get the x. So the 2's are canceling because one stays on the top, the other one moves to the bottom. And then the x has to bump back up because it still has a negative exponent. Questions? The last part of this question says, what is the domain? We still have to state the domain. The domain is not negative infinity to positive infinity. Nina?
Negative infinity to 0 and 0 to positive.
And why would it be 0? You're right.
Because x can't equal 0.
Yeah, so looking at your original equation, either the one inside or the one you started with, this x to the negative 1 really means that x is in the denominator. And x cannot equal 0. So even though it's not in the denominator of the answer, it's whatever you're plugging in and your answer that's creating the domain. It's both parts. So we plugged in 2 over x. Well, that x can't equal 0. So it disappears from the answer. That notation disappears from the answer, but it's still part of the domain of the solution. So negative infinity to 0 and then 0 to infinity. Questions on that? So today we're going to wrap up inverse functions. In your packet, we're at the very bottom of page 18. So on Friday we stopped, we ended with class with graphing an inverse to try and see how an inverse and a original function was related. So we stopped in the middle of page 18 with example 4. So page 18, the very bottom. So just a little refresher from Friday, we graphed x squared, which was a parabola, but we only graphed the right side of the parabola on Friday because it told us to only graph x values being greater than or equal to 0. So this was the graph that we had on Friday that you have in the middle of your paper. And then we also graphed the inverse, which is this like graph that it should look pretty much the opposite. So the inverse is the opposite of your equation. So if my first equation curved one way, then the inverse should curve the opposite way. So if it's a curve, they should kind of do the opposite of what the original curve does. At the bottom of this page, it talks about something called the horizontal line test. What's the vertical line test? Ethan?
It's like when you look to see, like if you put a vertical line on the graph, it goes through 2 points and it's not a function.
Perfect. So the goal of the vertical line test is to take a graph and test to see if it's a function. You draw vertical lines, and as Ethan said, if it passes through one point, then it's not a function. Well, there's also a horizontal line test. But the horizontal line test isn't for determining if it's a function, it's for determining that the graph you have doesn't have an inverse. Because not every graph actually has an inverse that would be a function. So both have to be functions in order for it to work, and that's what we talked, like, we did that inverse definition on Monday, or on Friday, sorry, today's Monday. So your original graph has to be a function, but your inverse must also be a function for them to be inverses of each other. So both pieces have to have, kind of match together. So the horizontal line test says the inverse of a function is also a function, if and only if no horizontal line intersects the graph of f more than once. So essentially it's the same thing as the vertical line test, but now we're testing to see if there's an inverse by doing the horizontal line test. So it's still looking at a graph, drawing lines through the graph and seeing do they pass through the graph more than once, but now we're drawing horizontal lines through the graph. So if it doesn't pass the horizontal line test, then there's not an inverse that's a function, and you don't have to do anything with the problem. Just say it doesn't pass the horizontal line test, therefore you cannot find an inverse because that inverse wouldn't be a function to begin with. So just looking at the two pictures, this graph is a curved graph. We graphed these back in chapter 5. So we got this like little squiggly graph. So that would be the function that you're starting with. And we want to know, does that function have an inverse? So to determine if it has an inverse, you're just drawing horizontal lines through the graph and making sure those horizontal lines are only passing through your graph once. So this current graph would have an inverse, and we would be able to find it, and its inverse would also be a function. Whereas the graph on the right side, what kind of graph is this, if it's a U? A parabola. A parabola does not have an inverse because it's crossing through the graph twice. And if you just go, like, move your eyes up, wrong way, and just look at the graph that you have above. So the reason that on this graph that we had to cancel out part of the graph was because if we graphed the whole thing, it wouldn't pass the horizontal line test. So if it doesn't pass the horizontal line test, that means the new graph that you would make for the inverse wouldn't be a function because this graph would come down like this. This new inverse is not a function. So to kind of force it to have an inverse, we made sure that we only picked half of the graph. So on Friday, we just picked half of the graph so that we were just looking at one side so that it would have an inverse, and then that one side is also a function. So if you flip it over, it makes a little more sense when you like look at an actual example. If you have a calculator out, I think some of you have, maybe someone has a calculator on your desk. If you could graph 2x cubed plus 1 in your calculator, you might remember what it looks like, maybe not. Make yourself just a tiny little sketch. It doesn't have to be huge, it doesn't have to be fancy. But you're graphing 2x cubed plus 1. Anybody give me a little air drawing of what it looks like? Ethan? Perfect. So Ethan said that little, yeah, he moved it up a little bit. So starts on the bottom goes down, the top goes up, and it's going to cross over somewhere like that. Because this little plus 1 is moving the graph up 1. So something like that. So does this pass the horizontal line test? It does. This little part here isn't actually flat. It just kind of keeps going. So it does have an inverse. It passes the horizontal line test. So it says, determine whether the inverse of f is a function. So if it passes the horizontal line test, the inverse is a function. Then it says, if it is, find it. So from Friday, can anybody explain how we find an inverse? Scott?
You put the x where the y is.
Yeah, so wherever you see a y, we're making that x, and what was x becomes y. So essentially, we're doing the opposite variable. So x is equal to 2y cubed plus 1. And then what do you do, Scott?
Then you solve.
Yeah, now we have to solve for y. So we would take the 1 to the other side, divide by 2, and then you have to figure out how to get y by itself. Well, if it's cubed, how do you get it by itself? Cube root it. So we'll take the cube root of the entire side on the left, and then the cube root of the y. So y cubed and taking the cube root cancels it out. So your function notation, we started with the function f. Its inverse is the cube root of x minus 1 over 2. If we graph that function that we just came up with, that inverse, it would also be a function. That's what the vertical or this horizontal line test is telling us. So if you look at letter B, without doing any calculator work for letter B, what's absolute value look like?
A B.
A V. So letter B has the absolute value. It looks like a V. What's the plus 7 do to the graph? Moves it up. So it's taking the vertex and just bumping it up on the graph. So it's starting up higher instead of starting at 0, 0. Nina, does this pass the horizontal line test?
No.
No. Crosses through it twice. That means there is no inverse. The inverse would not be a function. If it's not a function, you can't find it. So it would not have an inverse that we could find that would still remain a function. So you don't do anything with that. You're done. The last one says we're graphing h of x to be x squared plus 2, but we're only graphing the part where x is greater than or equal to 0. So what's this graph look like? So x squared, what's x squared look like? Parabola, but the parabola starts up a little bit. And if it's the x greater than or equal to 0, we need this side on the right where the x is greater than or equal to 0. So we don't have the side over here on the left that actually makes it a u. That's not the piece that we're looking at. So the reason we're doing that is so that it passes the horizontal line test, because now you're just looking at the right side. So again, yes, this has an inverse. And then it says to find it. So find the inverse, switch x and y, and then solve for y again. So we'd subtract 2. And Julia, this time to get y by itself, we have to
You have to add 2. Well, change the x and y.
So we change x and y, I subtracted 2,
And
How
then
do
you
you
do the square root.
and then you do the square root. Yeah. This letter is an h because it's relating to function h that we started with, and then we have the square root of x minus 2. Questions? Questions with finding an inverse, the proper way of finding an inverse, checking to see if it's an inverse. So horizontal line test tells you that the inverse is a function, and if it is a function, then you find it. If it isn't, you're done with the problem. Nina, I'm holding true to my word on Friday, right?
No way.
So you have about 13 minutes. The directions are on the board and also on the assignment sheet for how you're doing this worksheet. You have the solutions already because that was on the half sheet of paper that you picked up. So that half sheet of paper has all the answers.
Honestly, I've been waiting for this all weekend.
Best day of my life.
All weekend.
I only wanted to go after school for this one day.
Yeah, actually. Are you okay?
Really? That makes sense. So make sure that 1 through 12 are on a separate piece of paper. 7 through 12. I can't really give you an answer to that because that's where you're verifying f of g of x, g of f of x. But on the answer sheet, I did remind you that that's what you're supposed to do for those problems. So please get to work, use this time wisely.
Oh, so we're basically just doing the whole one.
The graph parts are pretty easy.
You don't need graph.
I need to snack so smile back.
Zach, are you working with us? Are you staying here to work with us?
Where? I mean, it's short.
One of my families.
Cooper, sit on the ground right here.
I'm so sad.
Zach.
I'm here, Cooper.